Welcome to this deep dive into OAuth 2.0, the industry standard framework for delegated authorization. In this course, you will learn to build a fully functional OAuth ecosystem from the ground up. Harris begins by breaking down the four essential roles: resource owner, client, authorization server, and resource server, before going into modern security must-haves like PKCE. You'll learn to code your own authorization and resource servers, implement a client app, and even troubleshoot real-world errors like JWKS and Axios 400 issues. By the end, you'll have the practical expertise to implement secure, professional-grade authorization in any modern web application.
Today we're going to be doing OAuth 2.0 and how this is an industry standard authorization framework that lets users grant third-party applications limited access to their data like photos or contacts on another service like Google or Facebook. And it doesn't allow them to actually share their actual passwords, but we use temporary access tokens for secure delegated access across web, mobile, and desktop apps. It has been a very popular method and people use it widely for their apps, like sign in with Google or Facebook buttons, connecting apps like a fitness tracker to your health data, web and mobile apps, accessing cloud storage or social media data seamlessly. This tutorial is going to be covered in Node.js, and I will cover the following topics, which will be creating an authorization server, which is allowing us to issue tokens. We're going to create a resource server, which protects an API and validates the tokens. And we're also going to be creating the client app that does authorization code plus PKCE, then calls a protected API. So this is going to be the cleanest way to explain OAuth 2.0 because viewers can kind of see the full picture, and I'll keep concepts simple and tie them directly to the code. So before even diving in, we'll explain what OAuth 2.0 in simple terms. And like I mentioned before, it's kind of like a secure valet key system. So you as the user own the car, your data, right? An app wants to drive your car for a specific purpose, like read your profile, post a message. So OAuth is the process where you approve that what the app can do, and you limit scopes or permissions. The app gets a short-lived key, which is the access token that lets it call APIs, and the app does not learn your password. Important to note is OAuth is mainly for authorization, what an app can do. And authentication, like who are you, is usually handled via OpenID Connect on top of OAuth. So those are very important things to understand. And let's go ahead and just open up our directory here in Visual Studio Code. So I'm going to go here and I'm going to open up with code. So here you have an empty state, and we just have a folder created as OAuth 2.0. Now the four OAuth rules you'll reference are the resource owner, which is the user. Okay, that's you. The client, the app that trying to access the data, our client app that we could create. And the authorization server is the server that logs the user in and issues tokens, auth server. And then we have the resource server, the API holding protected data resource server. Now, tokens in simple terms are like authorization code. They a temporary kind of like receipt that's created after login and exchange for tokens. We access token is kind of like a short-lived token used to call APIs, what we'll use. And the last thing what we're talking about is a refresh token, and it's a longer-lived token used to get new access tokens will include it. So why PKCE matters. So let me just go ahead and open up a text file, or I'll call it node.txt. Okay. So one thing I want to actually bring up is what PKCE is, right? So if I go here and just open this up and I say, okay, PKCE, right? What is this? So it protects the authorization code flow for public clients, like the app that can't keep secrets safely, like SPAs and mobile apps. So what PKCE is like if a client creates a secret random string, like suppose the secret random string is called code verifier. Okay. Client hashes it to create code challenge, okay? Client sends code challenge, okay? And in authorize, so it would pass it to authorize. When exchanging the code in token, okay? Client sends code verifier, okay? It would send this one. Now what happens is that Auth server hashes the verifier and checks it matches the challenge, which is basically it's hashed, and when you bring it back, it would turn into code challenge. So even if someone steals the authorization code, they can't exchange it without the verifier, okay? So let's have a project set up. This will make more and more sense as we go throughout this project. So I'm just gonna delete this, and I'm gonna start with clean folder, which is OAuth node and 2.0. So after that, we'll just create a folder in here. So I'm just gonna go here, and I'm gonna say new folder, and I'm gonna call this one as OAuth node demo. Now we could like cd in here. So if I go here, cd OAuth node demo, and then once we're over here, we don't need this one, but we can just open. So we can open this up in code. So now that we are over here, we can go ahead and we have to create 3 different folders. So this is a new folder button. One is the auth server, like I was mentioning in the beginning. We will create that. Then the other folder is the resource server. And the last one that we'll create is the client app. Okay, so we have to make sure they're all independent folders. So client app, okay. So now these 3 folders are created. We will run auth server on localhost port 3000, the client app on localhost port 4000, and the resource server on localhost port 5000. Okay, 3000, 4000, and 5000. We're gonna build the authorization server, which is which issues the tokens. Okay, this is the server that logs you in, will simulate login for demo. It'll create authorization codes and exchanges codes for tokens, and then publishes the public keys via JWKS, so APIs can verify tokens. Now we're gonna have to go into this auth server. So again, we can go here, auth server, and then open code. So we have a new one here. So within the auth server, what we can do is we can open up the terminal here, control and backtick. And right here, what we can do is we can say npm hyphen or init hyphen y. So you can see over here, it created this JSON, and it has the auth server, version, description, main, which is index.js, scripts, keywords, author, and license, ISC. Now, if we do npm I express cookie parser, body parser, and Jose. So we are going to use these particular libraries, and you're going to see them being populated within here. So in the dependencies, you can see over here. Okay. And you can see also that our node modules has been created, and the package-lock.json is also there. Okay. So far, so good. We can use Jose because it's modern and handles JWT or JWKS correctly. And if you want to learn more about JWT, I have a video separate on my YouTube channel, Coding Cleverly, so you can go and check it out. Now we're going to set ESM mode, which is in the auth server. So we're gonna in the package JSON file, and we're gonna add a type here. So you can see over here, there's these things, but right after the dependencies, okay. So you can add a comma, and then you can add type, and you can just say module, okay. Now we also have we have to create an index.js file. So we'll create a file here, and this one called index.js. For index.js, we kind of need to add a couple of things so that it can start running importantly. We'll have to generate a real private key and paste it into the private key PEM environment variable, and then we also have viewers that don't need to understand key formats deeply, but they should run a command, and we're going to have to use OpenSSL inside the Auth server to generate those private PEMs, then copy the contents of private PKCS 8 PEM into the private key PEM. So what I'm going to do is, first of all, I'm going to make sure we have the following imports in the index.js file. So we're going to have import express from express. We have import body parser from body parser. Okay, and then we have import cookie parser from cookie parser. We have import random bytes, and then we also have create hash from crypto, and we also need to have import sign JWT, and we have export JWK, and we have import PKCE S8 from Jose. So let's create the application, which is const application express. We also have the app.use. We're going to use the body parser dot URL encoded, and then extended is not true but false. And then we also have app.use body parser .json, and we also have app.use cookie parser. Okay, so now that we have done most of this section, you got to understand OAuth server basics, which the authorize folder, okay, creates an authorization code, and then it redirects back to client, and then the /token folder exchanges code for the access token, and then we have the /well known, and inside it would be a JWKS.json file, and that kind of publishes public keys, so resource servers can verify the JWTs, okay, JSON web tokens, which are JWTs. Now, a demo data store in production use DB or Redis, so we can have const clients, let's see, spelling, CLIENTS is equal to new map, okay. Then we have const authorization codes is equal to new map, and we have const refresh tokens is equal to new map, and then we have a registering a demo client, a public client, so we have clients.set, and then we have demo client. And then in here we have the client ID, which is the demo client. And we have the redirect URIs. And that is basically HTTP colon 2// localhost and port, 4000 and slash callback. Okay. So we don't need a comma after that, or we'll just keep it, but we need to make sure we close that with a semicolon here. Now over here we have the next section is the JWT signing key. So in production, rotate keys and store safely. A real PKCS 8 private key string should be used. For the tutorial, we kind of would create one quickly. For a clean tutorial repo, you can generate this key once and keep it in your environment variables. So let's just have a random private key pem, okay? And then we have begin private key, and then we have a random private key, and then we have an end private key. It's kind of like this, how it's created, okay? So we'll just have something randomly generated, just like this. So after that, okay, I think I mentioned one thing here is we don't need that, so we don't need multiple, but this is the backtick, and it's kind of done. So that's there, and one important thing is to make sure we replace the above with a real private key. This is just a dummy one that we created. And a quick way to generate for your repo is using OpenSSL genpkey and -algorithm RSA. And we just kind of use the OpenSSL commands with PKCS8 to generate those private keys for us. And after that, you also need to specify your issuer. Okay. And you can have the localhost 3000 set up here. We can also have the const key ID, and that should be set to demo key, and then we have 1. Okay. So I'm gonna make sure that we are using a particular quote. I would recommend using double quotes throughout the entire app. So stick with 1 quotations. And over here, what we can do is we can have demo key 1. Okay. After that, we have a function, and we have base 64 URL, and inside here we'll have the input, and it would return the input dot to string, and we'll have the base 64, and we'll kind of replace that dot replace with the slash, and then we have backslash plus slash g, and then we'll have dash dot replace. And then we also have the slash, then backslash, and then we have slash slash g, comma, and then we have the dash here. Okay, dot r dot replace, and I think this is how it's supposed to be done. So we have slash equal plus dollar slash, and then you have a g over here, and then we have comma, and then we have that. So this is basically our base64 URL function. We also need a function for SHA-256 base URL, and that should be something like this. So this is going to be SHA-256 base 64 URL, pass in a string as the input, and it creates the hash with the SHA-256 input parameter, and then it has the update.string.digest, and it returns a base 64 URL hash. We also need to have the generate code function. It would kind of have a random bytes of 32, so it would look something similar to this. And we also have a demo login, so we have to make sure we kind of simulate that. Returns Alice, which is sub name is Alice example, email is alice@example.com. Now after that we have different authorizations. So we have to make sure our app.get has a proper query parameter validation script. Otherwise it won't match properly. So I would add some of these sections and I will explain line by line what they all mean. So here we have the authorized rec request and response, and we have these response type, client ID, redirect URI, scope, state, and code challenge, which also has the code challenge method, and the request.query. We also have basic validation that we've already been doing, and making sure that unknown client IDs and only those are required so that it doesn't mess up. We have a normal show login plus consent UIF for tutorial simplicity, auto login, and auto consent. So this will just give you some of that demo, get demo user and all that. And then we have a redirect new URL redirect, and we also have the params to search with code set. And we have the state if redirect.search params.set and current state, and we also have the redirect to string. We also have this post token async function, which has the grant type, and we also have a grant type, which is authorization code, along with the authorization statuses. If it's 400, we have an invalid grant, but when it's something like this one, which is less than the date, expires at, which is less than the date.now, which is an invalid grant. We also have if it's not equal to the client ID, if the record client ID does not equal to the client ID, or the record.redirect URI does not equal to the redirect URI, we also have an invalid grant 400, which is a client mismatch. We have the PKCE validation, which is computed challenge SHA-256 base 64 URL. Code verifier, and if that computed challenge is not equal to the record code challenge, we kind of throw out a invalid grant, which is a PKCE validation failed. We also have one-time use code, which is authorization codes.delete code. We also have a create JWKS access token, and we're using the private key variable as the await import PKCS 8 private key PEM. It's not the dummy that we had, and we also pass in the 256 RS256 here as the second input argument. And then we also have the access token, which has the new signed JWT, has a scope, name, and the email. And we're coming through those records, and we're going to make sure that they have all these parameters set as the RS256, and the key ID also has the issuer, client ID records user.sub, and 15 minutes for expiration time, and refresh token set for generate code, and making sure that all of these parameters are set. We have the return response.json, we have the access token, we have the bearer, we have the expires in 900, refresh token, and scope record.scope. We have grant type, which is the refresh token, and it has make sure that all of these are specified, and if the record doesn't match, we throw out again invalid grant, and if they don't match again, another invalid grant. So we have a private key, and we have the import, and we have the returning the response of the base of the JSON. We also have the response.status, which is 400, and unsupported grant type, making sure that we have the app.get, which is well-known JWKS.json. We have the import of this RS256, and we're making sure we're using these key simplicity. This is Jose exports JWK for a key object, but we need a public JWK. For tutorial simplicity, like Jose can export from private key to it includes like public parts. So that's why we have that, and then we have response.json, which has the key set to JWK. Now this is the code which is allowing us to run it on port 3000, which is app.listen3000, and it has an arrow function set to console.log auth server running on localhost port 3000. Now, since all of this is there, you can see that important notes here is that one is that you must like generate a real private key and paste it into the private key pem. So if you go here, private key pem, if I like search here, this one, viewers don't need to understand key formats deeply, but they should run a command. Use this one which you kind of want to understand, which is inside auth server. So if I go here, so I'm in an auth server, and I'll show you, what command has to be run. So it's this one, and it's this one. So we have these two commands that need to be run, open SSL, and if we run these, it will create us those contents of PEM into private PKCS 8 into the private key PEM, and after that we have build up a resource server. So you could run these using PowerShell. I experienced it. Maybe it worked. Let's see. So go ahead and we run this. So if I go here, CLS. Okay. Okay, so it doesn't run because it's in, I think, PowerShell, but it's going to run in Linux environments. So if you have Git Bash, I think I don't have it. Let's see. Git Bash. Okay, I do have it. So we kind of run and make sure we're in the same directory. Okay. Okay, so it doesn't even know which directory they're in. ls. Okay, one second. ls, and we have all these folders, but we need to make sure we're in the documents folder, which is this one. So we can just say cd documents. Okay, cd docu. Okay, and ls. Now you have a bunch of other folders, but the thing is that what we want is we want this one, and it's not going to work until you have the path, as forward slashes. So yeah, I mean it's you're gonna have to go through that. One way what we can do is if you want to just see the running of those commands, like I could show you those. So if you go here, first command is this one, and I'll just paste it here. Open SSL genplay. So you can see what this is what happened in the documents folder. So you can go here, copy address, and you can just paste it here. Okay, so just go to the documents folder here. I assume we're in the documents folder of GNG. Okay, so here, let's say item modified. So type. Okay, so over here we have. Okay. Yeah, there's a private key. See that? Now we have that. We can also run the other command that was given to us, and that was this one. Okay, okay, it's this one. So we can run this second one. Open SSL, copy all that, and then we go back to this one, which is over here, and run that command right here. So you can see over here, this was the second command, and the date for the modification was updated. And if you go back, that's the output of it. You can go and open this up in Notepad. you can see this is kind of the private key. So you can just copy from the beginning to the end. Okay, and just copy that. Go here into the section here. Just replace that one with this one. Okay, and we're all good. So yeah, I mean, this was basically the section that I wanted to just discuss. Go back here, and this is the auth server. We need to build a resource server, the API that validates the tokens now. So if you go to the project again, which is over here, and you'll see then the resource server is up here. We can open this one up in another instance of Visual Studio Code. And what we can do with this one is that now we'll have to have this server is the protected API. It will like kind of read authorization bearer token. It will fetch the JWKS from auth server. It will also verify token signature, plus issuer, plus audience, plus expiry, all of that kind of good stuff. Also allow request only if token is valid. So we'll have to install the dependencies. So making sure we're opened up the terminal here, we can go and just make it a little bigger. And let's say we have the npm init -y, which is going to generate the package.json file. After that, we have the npm I express, and we also have Jose as well. So this is going to install those for us. We have to make sure we go to the package.json, just like how we did the other one, and go here at the end. And right after that, we'll just add in type module. Okay. After that, we have is the resource server. Inside here, we'll create an index.js file. Okay. Okay, I created a folder. Let me delete that. And we need an index.js file, not in the node modules, but just outside of it. We'll just create one thing called index.js. Okay. Now in the index.js file, we'll have some imports. Import web express from express. And then we just keep going in. And we'll say import JWT verify from Jose. Okay. We also need one more thing, which is the create remote JWK set. And that is all coming from Jose. So we're good with that. You can see it's a little dimmed out because it's not active. We're not using them. But once we use them within our code, they're going to start lighting up. So we have app is equal to express, and apps using the express.json, very classical. We have a const issuer. So the const issuer is equal to the localhost, but we're not running on port 9000, but we're running on port 3000. We have a const audience, and that's the demo client. So let me go here, and that is demo client that we're going to have the audience as. We have a const JWKS URL, new URL, and we're going to use just double quotes here. I'm going to say http :// localhost port 3000 and well-known JWKS.json. Perfect. After that, we have the Jose helper that fetches and caches the JWKS automatically. So we have const JWKS is equal to create remote JWK set, and we have JWKS as the URL. We have the async function, and then we can say that as the require auth. We have the request, response, and next. Inside here we have const authorization is set to request.headers.authorization. And if we have the authentication as authorize auth, we have not auth, and then we have starts with, and then we have bearer, and then we have return resource response.status 401, and then we have .json, and then we have error, we have missing underscore token. Now, after all of that, okay, we're gonna have, there's one problem here is we don't have a closing bracket for that. So that should be set for this one. So there you go. And now you can also apply that semicolon here. Okay. And since there was a closing bracket we didn't add right now, we'll just keep it because it's in the require authorization function. So we just keep going down. You can also just keep it like that. So, I mean, so it's not going to complain. And then over here, you can add in a const token is equal to authorization dot slice, and we have the bearer, and the bearer has the dot length, and we also have a try catch block. So in the try, we have a const payload. Okay. And the payload is set to await. Okay, let me just fix that up, the formatting here. Okay, payload is set to await JWT verify, which has the token in JWKS. Issuer is the issuer, audience is the audience, and then it closes like this. Okay. Okay, let's okay, there you go. Now we also have one other thing here, which is the request.user.payload, and then we have the next function. We also have the catch block, and in the catch block we have return response status 401, and then we have invalid token. You can also have a message printed out as well, so we just say message colon error.message. Okay, so all of that should be good. If we go and zoom out a little, this is how our function looks like. So this one require authorization. So after that, we have the require scope function. And in the require scope function, it kind of looks similar to this. And here we have a request response next as well. And we're going to make sure we're using scopes as string. And we split them and filter them based on the Boolean. And we also have the scopes include scope, return the response of 403, insufficient scope, and the required as next. After that, we also have the app.get, which is the API profile, and we also have the other section here. So API profile and require authorization, require scope, API read, require response, and then we have the response JSON, message, user, and we have all of this. And then we have the listen function. So we're going to listen on port 5000 this time, and we're going to say running server on localhost port 5000. The resource server does not trust the client, okay? It only trusts tokens that are this server we're creating, okay? It only trusts tokens that are signed by the auth server's key, the first thing that we created. Not expired and issued by the correct issuer, which is ISS, and intended for this audience, which is AUD. Scopes are how we enforce what is allowed. And now we have to go ahead and move on to the next section. Let me go here. So we had the auth server, the resource server, auth server, and the resource server is basically is the thing that, which I mentioned, does not trust the client app, and it will only trust tokens that are signed by the auth server's key. Okay, and not expired, and issued by the correct issuer and intended for the audience. So that's what the resource server would do, right? Uh, it will only trust those tokens from the auth server. And once that are done, what we can do is we can build the client app. So let's go here. We're going to create a new folder or open it up in VS Code. Now, the client app, which is the authorization code and the PKCE, this app will kind of send the user to authorize, which is the /authorize folder or route. It will receive the code in /callback. It would exchange the code plus code verify at /token and call the resource server. And then we're created over here. So if we go back, here, so this is the resource server, so what the client app would do is send the user to the /authorize path. It would go and receive code in /callback. It would exchange the code plus the code verifier plus this /token. It'll call the resource server, which we created over here, with authorization bearer. Now, let's go back to the folder for client app and open this up in a terminal and dedicated here. And what we're going to do is I'm going to make sure we have the npm init -y, and we also have the npm I express cookie parser, and we have Axios. All right, all of that should be installed. And let's go to the package.json, just like how we normally do, just comma here, and not dev dependencies, but we have the, so let me go back. Okay, so this is the express. We don't have a type here. I normally version description main, people used to add it here in the keyword section, so main, and then we have type. Come on, why is the thing not running? Maybe it's because, yeah, I'll just keep it consistent how I'm doing it. So I'm just going to keep it here on the bottom, even though it's not going to be the best practice to include it. So I'm just going to, okay, type, and then we have the double quotes module. Create the client app index.js. So we go here. And in here, we're going to create a very simple index.js, which uses a lot of the things that we've been using before. So I'm going to explain it line by line. Let's go here. The first thing is we're having express, cookie parser, Axios, and random bytes, and create hash from crypto. We are using the initialization for express, and we also use the cookie parser. We have the auth server at port 3000. We have the resource server, which is at port 5000. And the client ID is demo client, and we also have the redirect URI, which is a 4000 callback. And we have a base64 URL input, which is setting all that, which was there before. Now, also inside the helper functions, we have generate verifier, we have code challenges S256, and we also have the generate state, also have the get, the login, and the response cookies, and all those other important necessary stuff to get the app running on port 4000 localhost. So if we go here, we have all of this, like we mentioned, generate verifier, the code challenge S256, and the generate state. Okay, and we also have the slash that goes to request and response, and we send a client app. This app uses authorization code, and we have the login. And this is a login path which has the generate verify, the code challenges of S256. We have the code verifier and the generate state. We also have the response code verifier with code verifier range HTTP only, which is true, and we have the resource of OAuth state and the state of HTTP true as well. And these are the authentication pieces. We have the authorized URL search params, and we have the redirect authorized URL to string. We have the callback function that kind of calls back, making sure that the token response exchanges the code for a token. And we have the grant type, which is authorization code. Code redirect URI is set to that. Client ID is a client ID, and the code verifier, which is a two-string of headers with content of XWWW form URL encoded. And we have a const access token and refresh token expires in, which is the token response.data. And the access token has this, which is set to true. Response code token as well as that set to true. We have the send logged in and making sure all of that is accessed. And the profile has all of these Axios.get authorization and a stringify, making sure the strings are called and matched according to what the API call has been updated to. The refresh URL has the tokens, and the refresh token has the token at rest response. And it has the headers, which has the content, and the cookies access token, and the send, which is what we're doing, which along with listening to the port of 4000. So the slash login starts, what we see over here. We go to this one. There's different functions: slash login, slash callback, slash profile, slash refresh. Okay, so let me explain this so that you understand it in a very simplistic manner. This one is just a get function, okay? This is a normal get function, and it's just going to show out the client app. Okay, so these are all the HTTP endpoints, and the slash login one is, it starts OAuth by building a URL to slash authorize, okay? You can see over here. We generate the state, protects against CSRF. That's a big issue. We also code verifier. You can see over here our secret PKCE value. We have the code challenge. That one is going to be for the hash of verifier that we safely send to auth server. Okay. And we have the slash callback, which kind of receives the code. Then we call slash token. In the slash callback, we have a lot of the code that we need, and we call slash token with a code verifier to prove it's really us. Then we call the protected API using authorization bearer. Okay. Access token, allowing us to view and make sure everything is running according to what we're expecting it, right, to work for. And all of that is being done within the localhost port 4000. Now we have to run the full system. We need like 3 terminals opened up. So the first one is the auth server. So if we go to the, this is the auth server here. So we can open up the terminal. And we are going to do node, and we have index.js. So since auth server is running on port 3000, you can see over here it's running. Okay. We could go to the resource server, which is on the other side here, and we open up its terminal, and we do the same, which is node, and then we have index.js, and this is running on 5000. Okay, 3000, 5000. The resource server is running, the auth server is running. Now what we want is the client application to run. So let's go to the client application, which is this one. Open up its terminal as well. Clear that. And we run node index.js. And this is running on port 4000. Again, you can see over here, this one was the code that we gave with the slash only. And this app uses authorization code plus PKCE. Okay. Now, when we click login and we're logged in, you can see over here, callback, code, and then we have this very characterized string. So access token expires in 900 seconds. You should see the JSON from the resource server, okay? So now you see call protected API and refresh access token. If we call protected API, we have API call failed, error invalid token message, expected 200 OK from the JSON web keys set HTTP response, which is totally fine. But if we go back here and refresh the token, refresh access token, call protected API again, and it's giving the fail response. Now, you gotta have to understand one very important thing, making sure that all these applications are running and making sure that nothing is failing. So let's go back to here and log in and, just making sure we're in the entire resource code. The best practices that make this production grade is that we have the conventions to highlight clearly in the video, like always validate tokens on the resource server. In the resource server, we have to validate the tokens. Never trust the client. The API must verify signature via JWKS, the expiry, the issuer, the audience, the scopes. All of that has to be done through the resource server, which is going to be here. So the resource server validates tokens on the tokens. That's exactly what we did with JWT verifier, issuer, and audience, if you remember in our index.js that we created here. Then we have to keep access tokens short-lived. So we use like 15 minutes. The limits damage if leaked, and we use refresh tokens carefully because they store refresh. We store like the refresh tokens carefully and securely, rotate them in production, issue a new refresh token, each refresh invalidate old one, and add revocation logout. PKCE is mandatory for public clients, so this is a core modern best practice that we're using and adopting. And we use HTTPS in production. OAuth redirects and token exchanges must be protected by TLS. Common mistakes to demonstrate and great for a best tutorial is kind of what makes makes it real and teach it like how we debugging skills is like we make sure we understand that there's a lot of mistakes people do, and one is the state mismatch, the CSRF protection, and we remove the state cookie or change it to show error, and this prevents attacker-driven redirects. Also, another mistake is like the wrong audience. If we change the audience in resource server to something else, we show token rejected and explain the token wasn't meant for this API. Another mistake that's common is scope missing. Change requested scope to not include API.read and it shows 403 insufficient scope and explains OAuth is about permissions. After building this demo, most terms do not build their own. After building this, dummy demo, I wanted to demonstrate that most teams do not build their own OAuth servers from scratch. Instead, they use OAuth, Okta, AWS, Cognito, Azure AD or Keycloak, and implement client app flow, resource server validation via JWKS. But the reason we built this is so they understand what /authorize does, /token does, what PKCE exists, and what the resource server must check. So OAuth 2.0 is a secure way for apps to access APIs without passwords. And authorization code plus PKCE is the modern safe user login flow. Resource servers must validate JWT signatures and claims using JWKS and enforce scopes. Short-lived access tokens plus carefully handled refresh tokens reduce risk. So that's what I would want to demonstrate here. And one thing that I would say is, like, okay, we're logged in and we access call protected API, okay? And I copy this and I say, okay, I get this kind of response, okay? So I get the URL, which is this one, but the response is this thing. So this is kind of like an error that we want to fix, and it's common when like people build OAuth and JWT systems from scratch, and fixing it will actually make this better because you kind of explain how resource servers really verify tokens. Um, so let's walk through exactly the error, what it means, and how it's happening, and how to fix this. So this error we're seeing, this is the error is coming from the resource server, okay, not the client. So we're in the client, but it's coming from the resource server. And what it means in plain English is the resource server is trying to verify the access token. And to do that, it reads the JWT header, sees it's signed with RS-256, looks for the public signing key via the JWKS endpoint, and sends an HTTP request to localhost port 3000, well-known JWKS.json. But one of these is happening. That either the JWKS endpoint is not returning HTTP 200, or the JWKS response is malformed, or the key format is invalid for verification, or it could also mean the JWT KID does not match any key in the JWKS. When this happens, Jose throws this error, and that's what we're seeing. The root cause, I think, in the authorization server code that we provided, this part is incorrect for Jose verification. So go back here into the auth server. We have a const. So if you remember, there was a part which had this thing, which is const JWK await is equal to export private key. Now, this exports a private key JWK, not a public key JWK. And create remote JWK set expects public keys only. So that's why, as a result, the response server fails with the JWKS and the response exits. But it cannot find a valid public signing key. Verification fails, meaning expected 200 OK from the JSON web server set HTTP response. And the correct fix, what we'll do is we would generate one RSA key pair. We use the generate key. We use the private key to sign tokens, and we publish only the public key in the JWKS endpoint. So we're going to generate keys properly from inside the auth server. Remember, again, I was trying to go inside here. We have to run the OpenSSL commands, and we will have now private.pem and public.pem used to verify and update authorization server key handling. Replace the part in the auth server index.js, and we'll remove and replace it and load keys correctly and fix the token, fix the JWKS, and it should work. So what we want to do is, first we have to generate keys properly inside the auth. We want to run that. So I would normally go and see where is this located. So first of all, making sure I know the path here. So it's in documents. After documents, we have projects. So we have here cd projects, should be over here. There you go, projects. And then we have OAuth 2.0. So cd OAuth 2.0. Okay, let's go back here. OAuth, there you go. After that, we're in the OAuth node demo. OAuth node demo. Now within the OAuth node demo, we have auth server. So we're going to go to cd auth server. Okay, we're in the auth server now, which is very good. And we're going to run the first OpenSSL command. So we're going to have the private.pem, paste it here. See all of that. And you'll see a reflection here. Okay. After that, we have the public.pem as well. So run that as well. Paste it. And there's the public.pem. Okay. Cool. Now we have private.pem, which is used to sign. Okay. And the public.pem is used to verify. We have update the authorization server key handling, and in the auth server index.js file. So remember that part where we were using this function? Let's go back here so that you can see it. Okay, import and go. Okay, so we're in the auth server. So remember the import that we were doing. I think it's somewhere over here. Import signed JWT export from Jose. We're going to replace it with this thing, which is, okay. Import fs from fs. Now load keys correctly. Add this near the top. So in the section, what we're going to do is we're going to make sure we also add. I'm just going to make sure after this, we'll have this added. Private key pem. Okay. Since it's already here, we can remove that issuer and key ID because all of that was there before. Or I could have just replaced it with that one section. So I'll just cut that and bring it here. Okay. So now that we have all of that there, we have to fix the /token signing code. So if you go to the private key await and the access token, if I go here, private key. Now import await, import all of that, 256. Okay, the access token, and we have this one. So if we go here to this section, access token, and then we have all of that. Okay, so this is kind of what we can do is we can just make sure we're using it correctly. So private key all the way to this section here. Place it with this one, just so that it's properly aligned. You can just use a tab to improve the spacing here. After that, we also have to fix the JWKS endpoint. This is the key fix. So remember the section where we're getting the app.get section over here. So well-known JWKS, we're going to replace it with this one. So like that. And since that is there, these fixes import the SPKI, imports a public key, export the JWK, exports it to a valid JWKS format, and the resource server can now fetch the key, match the KID, and verify the signature. Verify the JWKS endpoint manually, very important. So open the browser. If I run this application, it should be running. So if I go to the URL, this one. So right now you can see here, we're getting a type error. Okay. But when we finish it, we get a proper key signature. So what I can do right now is go back here and just have to verify that my public key and private key are being linked properly. So since we were using those, read file sync, okay, and they're in the same directory here. Turn this server off, restart it. Okay, and I think that was the auth server. Okay, so now you can see here, since I restarted the server, you can see something similar to this, which is keys, KTE, KTY, RSA, and all this being passed in. This is exactly correct. If N and E exist, which is over here and here, HTTP status is set to 200, then the resource servers will work, okay? Now we have to make sure we restart everything. We have to stop all servers. So let's stop this one. We'll stop this one. And we'll stop the client as well. So we'll stop all servers and restart in the order. First, auth server is going to run, then the resource server, and then the client app. Then we go back here. So the auth server will first run using node index.js. Then the resource server will run node index.js. And then the client app will run node index.js. Okay. So when all of these are running, we go to the localhost of port 4000, and we click on login. Now you can see over here, click call protected API, and then it should example see the JSON, but as we pass in or we click on this, I get the URL endpoint as, and the Axios error, I'm getting a status error. Okay. Okay, so we're gonna try to fix this Axio error, which is request failed. So we have, first we have to understand why we're getting this. We're getting this 400 error, and this error happens after the redirect succeeds. So we have a callback code, and then we have this thing, okay? This means like the /authorize worked, and the authorization code was created. Redirect state handling is correct. Failure happens during the step. We have client, which is post token exchange code plus code verified for tokens. We have a 400 from /token. Almost always means one of these is wrong with either the code verified, the redirect URI, authorization code already used or expired, and content type or the client ID mismatch. We'll diagnose. So so root cause, which is kind of it's like the client is losing the code verifier cookie between login and callback. This makes the line fail. This computer challenge because code verifier is undefined and the result is invalid grant 400. In client app, if we go back here, we have the console.log cookies and code verifier. We have to fix the if you go to callback function, which is right here, okay, so this is the callback function. I don't know where it ends. Okay, so we just end. Okay, we just write something like Okay. So let me just have this 2 lines added. If I get in the console, client app running on request failed with status 400, code verifier. So let me just run that, CLS, and then, okay. Node index.js, JS. Okay. Login. Okay, let's go back. Okay, we're getting access token, refresh token, code verifier, and OAuth state. So we're getting all of these paths in. Code verifier is this one, and then we have the Axios call. So if you look at this properly, so our error is failing in the profile section, and it's failing because the Axios get profile, and the Axios stack trace points to line 74, which is still the callback token exchange. The correct fix would be make the callback handle only the OAuth response. So if we go here, so the callback. So at the top of the callback, if you see over here, refresh profile, callback. So we have this section here, which is this one. So we have code request.query. Okay, we'll just add this section. It prevents accidental execution of callback without a code. Clear PKCE after the successful exchange. So once the token exchange succeeds, immediately delete the PKCE cookies. So after the cookie, you would see over here line this one. Const access token, refresh token. Const access token, refresh token, token, this one. This is all in the callback, right? So after this block, we'll just add the clear cookies code so that we have them cleared. And then it's critical OAuth hygiene. And once we're done with that, okay, so we're just going to make sure this is added. Sorry, this is added right after this one. And should be also resent. And we'll have the redirect. So instead of that, so over here you can see this send function. We'll just paste in the redirect. Hope that would help fix that. So the callback basically would be like that. Okay. So let's go here and let's go here. We also go here. Node index.js. Node index.js. Node index.js. Insufficient code, required API, and the reason why this Authorization PKCE is because we don't have the scale of it, but I hope you kind of understand this whole logic behind it. This was kind of a gist of this entire app, and the client never, you have to understand one thing, and that is the client never gets passwords, okay? The auth server never serves data, and the resource server never handles login. So that's basically it, and the refresh token rotation, and you can also have OIDC discovery and all this kind of stuff, but explanation of the roles is client. First of all, if you look at the client, which is this one, this is the app the user is using, okay? It asks for permissions, stores tokens, and calls APIs. Like it would say, please let me access this user's data, okay? The authorization server, which is this one, is the security authority. It logs users in and creates signed tokens. Yes, this app is allowed. Here's the cryptographic proof, okay? Cryptographic proof. And then the resource server, the API with the data, it does not trust apps, it trusts tokens. So it would say, show me a valid token and I'll return the data. Okay. So that's basically it. We'll just create a repo of this on GitHub so you can get an access to it. So I'm going to go here, sign in, and I'm going to go here, and we're going to create a repository. So one other repository I have is here, so I'll use the other one. And what I'm going to do is I'm going to make sure we have the repository created. So let's go here, create a new repository, and I'll call this as OAuth code project. Okay, and just gonna, you can turn on that if you want to, but we'll just create it like that. And now we can go to this one. I will just put it in here. So, okay, not in CM. What is that? CMD. So we have git init initialized. After that, we go to other commands like git add. So git add everything. Git commit. We have first commit, and then we have git branch -m main, git remote add origin. Let's copy this. And then we'd have git push -u origin main. So we have password authentication not supported for git operations. Alright, so one other thing I wanted to do is also show you that we can have GitHub Copilot help us. Okay, so let's see here. Okay, I want you to help me push this code on GitHub. First, write me a readme.md. Okay, so let's see what it does for us. And it's just going to create the readme file. Again, I'll create a short to-do list for adding the readme and pushing the. Just create it for me, okay? So once it's done, so I will allow that. It's a little slow, but yeah. Okay, cool. I don't know where it added it. I don't even see it, honestly. The repo root, where are you? Where is it? What is he even talking about? Okay, so let's go here and see why it's not running. So I try to run, or I try to push it. Okay, we're gonna have another token access because I think the old one expired or something. So we go to the settings. Of course, I'm gonna have to go to the developer options, personal access tokens, classic, and expired. So we're gonna have to create a new one. We have generate new token. So I'm gonna show you how to do it. I have to do it off screen because one thing you want is not to leak the data. So we'll just generate a new token. Okay, and just making sure it doesn't expire over some time. And then we can copy it and paste it here. Alright, so as I added that, now let's see, it should push it. Okay, we're getting a issue here. Let's see. Again, I pasted that. Okay, why am I getting that? I don't understand. So, let's see. I get this while pushing my code to GitHub. I added the personal access token classic as well during the sign-in box from GitHub. The 4.0 denied means GitHub authenticated you, but the token user you're using does not have the right access to the repository. Adding a pad in the sign-in box doesn't allow guaranteed permissions. So what it's going to do is it's going to say, what in the world is this? Clear stored GitHub credentials. Windows R. Control G. Windows R. And okay. Oh wow. The website credentials could be over here as well. Yeah, I did this a couple of times back as well. So it should be like Git somewhere. Microsoft account. I don't see any Git. Yeah, I don't see anything. Go to the Windows credentials, remove anything related to GitHub or this thing. No, Git will force you to re-authenticate because it's not there, right? It's not there. I saw there's nothing related to GitHub or Git. Re-push the inventory of the token correctly. So I'm going here and paste that. Again, it's going to ask me for this thing. And then there's the personal access token. I'll go and again, I have to stop this. And let's see. Okay, so it's still not working. I could go and show you the results here. So you can see over here we have GitHub, origin, fetch and push. I mean, it's the same thing. I set the origin properly. So you go back here. If this repo was created under a different account or organization, if you want, paste -v. So I mean, it's all there. All we have is a push, and it doesn't allow us. Just sign in with the code, sign in with your browser, and just gonna open that up, which is not what I want. I don't know what happened now. So yeah, main issue cannot be resolved to branch. That's what I'm getting. Okay. Okay. You're gonna have to change that. So git branch -m master main, and then push it to main. Why is it added random characters? Okay, it's not. Push it to the GitHub. Set upstream correctly. New origin master. I don't even know why, but it's not working, bro. Okay. We'll just add all this stuff. Let's see. It's not adding any of that. Okay. Use master instead of main if that's your branch. Alright, so let's go say git branch. Which branch are we in? Main. Git branch. Git checkout master. Alright, so let's just say, I don't know why it's not working. Just git branch. It's like sometimes it messes up, and then it's not gonna like access it completely. Okay, so yeah, this is what I'm getting better. So it's not master or branch is that one, so we're just gonna paste this one. Okay, why is it copying everything? We just need to copy that one. Oh, wow. Alrighty. Resolve merge, prompted, git status, add commit, push. I don't know why. This is the last case scenario. So you can see over here we have an issue. Ah, it's capital M. Don't tell me that, bro. That's the worst, man. Why in the world is it like that? So weird. Anyways, now that we are done that, you can see here the code is finally there. Okay? So hope you like this video. Please subscribe to Coding Cleverly. That's my YouTube channel, and thank you for watching this free CodeCamp tutorial. Hope you learned a lot about authentication, OAuth, and PKCE, and tokens, and all that good stuff. So stick around. See you around. Peace out.